Hi, boys and girls. So today we are going to start the next part of the unit, which is Unit 9B. It's going to be all about piecewise and step functions. So we're going to go ahead and get started. You can scroll past page 2 is just kind of an overview of piecewise, and then over here you can kind of just see all the transformations that you've learned so far. And we'll go ahead and start with piecewise functions day 1. So it says write the equation of each line in, it says slope-intercept form, but hopefully you know that that is slope-intercept form. So the way that we normally do that is you choose your 2 points on the line, and then we count our rise or run. So we're going up 2, and to the right 1, 2, 3. So our slope is 2 over 3, and it crosses our y-intercept at the value of 2. So our equation is y equals 2/3 x plus 2. I apologize for my handwriting. Can't figure out how to write neatly on this, so you're just going to have to bear with me. So B. Again, choose your 2 points. Any 2 points on the line are fine. You should start with the point on the left. We're going down 1, 2, so it would be a -2. And to the right 1 is a +1. So our slope is -2 over 1 or -2. As you can see, it doesn't hit the y-intercept. So what are we going to do in order to figure out, well, what is the y-intercept of this function? What we can do is continue the slope that we had and see where it would hit the y-intercept. So if our slope is down 2, right 1, we can also say it's up 2, left 1. So from this point, I'm going to go up 2 and left 1. Put a little dot. Up 2 and left 1. Okay, so our line would hit the y-axis at 1, 2, 3, 4, 5, 6. So our y-intercept is 6. We could take that and put it into y-intercept form. Y equals -2x plus 6. Okay, continuing on. Function A and function B are graphed on the same set of axes. Write down the domain of both functions in set notation. Now remember, domain are just your x values. So let's kind of label this for a second. Let's say this is function A, and this one is function B. What would be the domain of function A? Well, we see that it's going forever coming from the left side. And when we're coming from the left side, but there's an arrow over there, we know that we are at -infinity. So we know that we're going to have a -infinity. And -infinity is always just less than, no less than or equal to. And we notice that it kind of stops at this x value here of -1. So it's -infinity is less than, is less than x, which is less than -1. And then we can put our curly brackets around it for the set notation. Function B, I'll use a different color just to, spice it up. We start at -1 as the first number, and then even though the arrow is pointing upward, we also know it's infinitely going toward the right side. So the x value of -1, now this time it's going to be less than or equal to because of that solid circle. Before we had the open circle where we just had the less than, but because now it's a closed circle, we're going to have the less than or equal to, and then it goes all the way to the right, so less than infinity. Close it up with your set brackets. Now you may also see it as just -1 is less than or equal to x and no infinity sign, or for the one above, it may just be x is less than -1. So you can see those two different ways. That's just the way of writing domain for both of those functions. Okay, so this first question we're actually going to skip, and that's because you have to do it with a partner, and initially when we were going to do it in class, I was going to have you work together on the same graph, but we don't have that right now, so we are going to skip the first one, and we're going to kind of go right down below to the next question. So it says, a piecewise function is a function defined by at least 2 equations or pieces, each of which applies to a different part of the domain. Their pieces may all be linear or a combination of functional forms like constant, linear, quadratic, cubic, square root, cube root, exponential, and so on. So it says split the function into 2 pieces and graph it on the set of axes below. So it looks a lot more confusing than it is. Pretty much this function has 2 pieces. So your first piece is the top part, and the second piece is the bottom part. And what that really means is we're going to graph x plus 3 between the values of -5 and -2. So we're going to do -5, -4, -3, and -2. I'm also taking a look at the 2 symbols here and here to see if we're going to have a closed circle or an open circle. So at -5, we're going to have a closed. So I'm just going to maybe draw a little closed circle here. And at negative 2, we're going to have an open circle. So just to keep me, reminding me what it's going to look like. So to fill out the table, you can go ahead and pause the video, use your calculator, do it in your head, but go ahead and fill out the rest of this table. Okay, check your work. Hopefully you have the same values as I do. And then we can go ahead and do the same thing for the other equation. So the other equation is 1/2 x minus 2. And we're going to do it for all values greater than or equal to negative 2. So we'll put negative 2 first, and let's just finish filling out the table. So the next number greater than negative 2 is going to be negative 1, then 0, then 1, then 2, and finally 3. Now, you don't have to do them all. You can do them all, but pretty much we just know that this one is going to have an arrow. So once you get to that last point, we're going to continue this line, wherever it is, with an arrow. And at negative 2, we're going to have a closed circle. And again, I know that because of this symbol right here. There's the or equal to sign underneath it. So again, pause the video, fill out the table, and then you can check your work in just a moment. Okay, if you check your work, you'll notice that you have some decimals, which is okay. I wrote some fractions. I don't really know why, but I did. It's okay to have fractions and decimals. We are probably not going to, sorry, I just wrote something. We are probably not going to graph the fractions and decimals, but it's okay to put them on our table, so at least we know that we have them. Okay, so we're going to go ahead and graph our function on the left, and then we'll graph our function on the right. I don't know why this came with us. What's happening here? I don't know. I'm going to erase this. Okay, just know that this is a 3. Okay, so let's plot the points of the function on the left first. So we're at negative 5, negative 2, negative 4, negative 1, negative 3, 0, negative 2, 1. Okay, I also know that at negative 5, negative 2, I need to have a closed circle, so I'm going to make that a pretty obvious closed circle. And then at negative 2, negative 1, I need an open circle. So my dot's pretty big. I'm going to erase it just so that it's clearly a open circle. And then I'm just going to stop there. I'll connect it using a straight edge that I don't have, so my straight edge is pretty ugly. But if you can make a straight line, that'd be great. And then the other function, we're going to go ahead and graph as well. So negative 2, negative 3. And that's a closed circle, so I'll go ahead and make that closed. Negative 1, negative 2, 0. Oh, sorry, that was negative 1, negative 2.5. So I'm actually going to skip that one. I'm just going to graph 0, negative 2. I'll skip the 1, negative 0.5 because I don't really want to graph a decimal or fraction. We have 2, negative 1, 3 1/2, so I'm not going to draw that either. So I have the closed circle. And then remember over here, we should have an arrow. So I'm just going to continue this with an arrow. Okay, and that is your piecewise function. It's actually so much easier than it looks. You're just going to graph the functions for whatever domain it indicates. And then that's it. Now it's still a function because if I was going to draw a straight line there, it's still going to pass the vertical line test because technically right here, it only hits at one spot. Okay, I'd like you to go ahead and try number 2. Hopefully you see that we're no longer going to have 2 parts. We're going to have 3 parts or pieces. So we have this first one, this second one, and this third one. So the function x plus 1 with the domain x less than 1. We have 2 for the numbers between 1 and 3. And we have 2x minus 4 for the numbers that are greater than or equal to 3. So go ahead and try it. You might get a little bit confused, but that's okay. You're going to pause the video now, and then I will put up the key. Okay, here is the key for this one. Oop, too far. All right, so some things that you want to notice. Hopefully, you see, and I keep saying hopefully, but it's because I want you guys to recognize things. For the first function, you have that point 1, 2, and it's open, and then for the second function, you have that same point, but it's closed. So when you have open on one function and then it's supposed to be closed on the other, it just becomes a closed point. So if you look at the graph down here, the point 1, 2, again, it's right here. You notice how it started up being open, but it ends up being closed because it is a closed point. So if it's closed at any point in that function, at any piece, it becomes like a closed point because it is included. Now that also happens over here with the point 3, 2. So it's open for one of the functions, but then it's closed. So again, it becomes a closed point right there. So don't let that confuse you. There's an open and a closed. It just becomes a closed. The hardest part is really recognizing like where the arrows go. Okay. All right, let's go back to the next question. You can do these QR codes if you'd like to, but you don't have to. And we have option number 3. So it says the piecewise function below is already graphed for you. Using the graph, answer the following question. So they give us the function, they give us the graph. You actually already know how to do these, so it won't be too bad. So the first one is saying f of 2 equals. Now, that's showing you really when x is 2, what is y? So we'll look at where x is 2 here. And we're going to go up to see what y is. Now, that was a really bad line, but it's supposed to go through those 2 points. The first place it stops is this open circle, but since an open circle isn't included, we actually skip over this point right here, and we kind of keep going to this next point. So I would say when x is 2, y is about 4. The next one we have when x is 0, right here, and y is equal to 0. Then the last one says when f of x equals 1. F of x is the same thing as y, so really they're saying when y is equal to 1, what is x? So let's look at where y is 1, which is about right here. So what is x? X is approximately 1, and x is negative 1. So I'll write negative 1, 1. Okay. Then we keep going. And it says on the set of axes below, graph the piecewise function. So I'd like you to again stop the video and try and graph this one. Now I will tell you that when you put it in your calculator, so I guess I'll start you off on this one. The first one is negative 1/2 x, and then the second one is going to be just x. Since because there's a half in the first function, you're going to obviously get fractions when you try and find the y values. So you don't have to put them all down. You can start at once x is less than 2. So if 2 is your first value, you can go straight to 0, and then negative 2, and then negative 4, just so that you don't get fractions. You don't have to put every value in. But also realize that when you put this in the calculator, the negative numbers are going to be up here. So it's going to be like negative 4, negative 2, 0, 2. So you can write it any way that you want or any way that you feel comfortable with. Just make sure that it's the values that are less than 2. So that means the arrow is going to go this way and the open circle is going to be up here. And then for the other one, you're going to have, I really should choose different colors. You're going to have 2, and then it's greater values. So it's 3, 4, 5, and then it's going to keep going that way, but having a closed circle because of the are equal to. Okay, so graph it, and then pause the video, check, all that good stuff. Okay, go ahead, check your answers. Hopefully this helps. If you have any questions, please send me an email. Here's just the ending. That's it. Have a great day.